are at chapter 10, where you get the chance to learn more about making decisions. In this video, you'll get the hang of what logical expressions are and how you can use them in your program. You'll get to practice making simple decisions using logic in your program and get to try out more complex decision making to handle tougher situations. You'll get to write a program that uses decisions to figure out if a number is positive, negative, or zero. While sometimes we aren't too great at making decisions, computers are great at it. They can do it so quickly, but we need to give them really clear rules to follow to make those decisions. When it comes to our programs, decisions allow our program to take different paths based on the logic and the rules that we specify. So just like in life, choosing the right path in our code can make all the difference. So sometimes when we say logic in this video, what we really mean is a logical expression. Logical expressions evolve or revolve into they're either true or they're false. An example of that is, my age is less than 50. So if the value of the variable, my age, is less than 50, then this would be true. So if my age is 45, it's true. If my age is 55, it's false. We're going to use these logical expressions in the decisions that we make in programming, and we're also going to use them in loops in a later chapter. So there's different types of logical expressions that we can use. If you remember back to when we talked about variables, we used the assignment operator, which is an equal sign, right? So we set the value of a variable using equals. In a logical expression, we don't use equals, we use double equals. And double equals means that two things are the same. They look a lot alike, equals and double equals, so I just want to make sure you don't mix them up. Also, in logical expressions, we use an expression that is exclamation point equals. This means two things are different. We call that not equals. So here are a few of the types of expressions that we might use. Equality, so ABC is equal to, double equals, ABC. Inequality, ABC is not equal to DEF. Then we use and, that's two at signs. So 100 and 200 are greater than 50. And then an or, that's a pipe, two pipes. So 100 or 200 are greater than 50. And then the exclamation point for not. So 100 is greater than 50, not. That expression is not. That's kind of confusing. Let's get into it. Look at some simple examples here. So the first type of decision we're going to make is a simple decision. And in our program, this means that it's either going to run a little block of code or it's not. It's going to skip it. If it's true, it will run it. If it's false, it will skip it. It looks something like this. So if, logical expression, so if inside the parentheses that is true, then it's going to do something. Otherwise, it's just going to skip down out of the block. By the way, the squiggly braces here represent a block. Okay. Let's look at what a line of code might look like, or a couple lines of code. So if my age is greater than 64, so if that is true, then it's going to output, you are old enough to retire. So if it's not true, it's just going to skip down past this block of code and do whatever the next thing is. So that was a simple decision. This is we call a two-route decision. It's a little more complex because it's going to have two different routes. If it's true, it'll do one thing. If it's false, it'll do something else. It would look a little bit like, so if the logical expression is true, it does one thing, else it's going to do something else. All right, this is what it would look like from a coding standpoint. So if my age is greater than 64, then I'm going to output, you are old enough to retire. If it's false, else it's going to output, you are not old enough to retire. So you see how we added a little bit to that. So it's not just one route, it's two routes. It can get even more complex than that. In fact, it can get way more complex than that, just depending on what problems you're trying to solve. Like for instance, if the logical expression is true, we do one thing. If it's not true, then we actually put in another if statement and another logical expression that says, if this other logical expression is true, then do a second thing, else do a third thing. So this has three paths. but you could have 4 paths or 5 paths or however many. So we've been using this retirement example, and let's use it with this complex decision. Let's say we want to show a different message if you're under 55, if you're between 55 and 64, and if you're over 64. All 3 different messages. Well, the code would look like something like this. So if my age is less than 55, then I'm going to output, you are too young to retire. If it's false, then I'm going to go down to this else if. If my age is less than 64, then I'm going to say, you might be old enough to retire, else you are old enough to retire. So if we look at this a little bit, the first block here, or the first expression, so let's say that I'm 70 years old. If I'm less than 55, that's going to be false. Then I come to the second, the if else, and I come to this logical expression. If my age is less than 65, that's also going to be false. So I would get the line that says, you are old enough to retire. I don't have to have all 3 logical expressions here because I weed out the old guys, the people who are older than 64, meaning 65 and older. I weed them out by the combination of the 2. I hope that makes sense. We'll give you an opportunity here in a second to go through a couple of programs that hopefully will help to make this a little more clear for you. So the Learn section that we just covered talked about how a computer makes decisions. And now we're going to try what we've learned. Now, I hope that you've been able to take a few minutes and go through the chapter that talked about a coding process, because from now on, throughout our try sections, we're going to spend a couple of minutes talking about the coding process. And as a part of that process, we'll review some requirements, talk about pseudocode, and do those things before we ever start writing our program. This is really important to follow this type of a process because it gets your head in the right place to solve the problem that needs to be solved. Too often, as programmers, we just dive right in and start writing a program before we've thought through what the sequencing needs to be and how we're going to solve the problem in the best way. So, for this try, we're going to have requirements that are creating a program that collects a number from our user, our person, and determines whether the number is positive, negative, or 0. And after it's made that determination, it's going to present some output. Now, if we think about the sequencing of this, our pseudocode would be something like this. We'd ask the user to enter a number, and for this particular program, let's allow the person to either enter a number that has a decimal point or doesn't. Remember that an integer, or an int, as we've been using through a lot of our programs, only allows a number without a decimal point. So you'll have to use something that's not a decimal, not an integer. We're going to take that number we collect and store it in a variable. And then we're going to ask 3 questions. Is the number positive? If it is, we're going to display output of, you have entered a positive number. If it's negative, we're going to display the output of, you have entered a negative number. Or if it's 0, we're going to display an output of, you have entered a 0. Now, that is the information that we need to be able to move forward with writing our program. At this point, I'm going to assume that you've already listened through the part we talked about with requirements and pseudocode. It's really important that you go through that first and understand that before we start writing our program. And then, as we start to write our program, it's going to be much the same as usual. We're going to start in our IDE with source, right-click on New Java class. We're going to call this one my positive number program and hit enter. Because we're using input here, we're going to put in our import statement. Just like we've done on several of the others, we're also going to start public static void main. Okay, we're going to set up our scanner like we've done on others, creating an object called input. Now we're going to create a variable. Now the pseudocode suggested that we should be collecting a number that could have a decimal point. So we're going to instantiate, or we're going to declare a variable that's of type float. Now we haven't done this on any of our tries before, so this is new. We're going to follow the same input pattern that we have, where we start with a label. So we'll do that. System out print. We're going to say enter a number. Okay, all this should be pretty similar to everything else we've done. Now we're going to collect that number from the keyboard, and when we've hit enter after collecting the number, we're going to put it in our variable called number. Now because we're using a float here, rather than using int or next line, we're going to have next float. Instead, it's going to make sure we type in a float. All right, now let's talk about the decision making. We've got our 3 different decisions we need to make: negative, positive, 0. So let's start with a negative. We'll use an if statement. We're going to say if the number is less than 0. Remember that this less than sign, less than, that's important. We get that going in the right direction. Then we're going to output system out print line. You have entered a negative number. Okay. Now, if it's not a negative number, we say else. Now we need to find out if it's a positive number. So, by the way, the decision that we're making here is a complex decision, like we learned about in the learn section for complex decisions. It's not going to have a single route or 2 routes. It's going to have 3 routes. It's going to have a route for negative, a route for positive, and a route for 0. So we need to have another if statement here. If number is greater than 0, okay, then we're going to go system out print line. You have entered a positive number, okay? And then we're going to have an if here. Now the reason why we don't have to have another if statement is, if the number isn't a negative number, and if the number isn't a positive number, then by definition, it's 0. Okay, now let's make sure we got all of our program right. Make sure you don't have any red underlines or anything like that. Make sure you've spelled everything right. You've got all of your squiggly braces set up the way they need to be set up. All right, now we're going to actually run this program 3 different times to get the 3 different results, to kind of test it, to make sure it works correctly. So let's come over here and right click and run our program. And remember, it runs until it gets to the input line right here, and it waits for us. So for the first one, let's try a positive number. I don't know, let's try 25 and hit enter. So once we hit enter, then it goes through our if statement and makes a decision on what to display. You have entered a positive number. All right, that looks right. Okay, so let's come back, run it again. Now this time around, let's do something different. We're going to add a negative number. And for that matter, let's make it a decimal point base number. Let's just say minus 10.5. Hit enter. We know that if it works, we have our float set up right. You have entered a negative number. All right, now let's run it one more time. And this time around, let's put a 0. You could even put 0.000000. That's still 0, right? Hit enter. There. You have entered a 0. Congratulations, it worked. Now, if you got different results than what we just went through, come back and especially look at your if statement. Make sure this is a less than symbol for the negative. Make sure you have a greater than symbol for a positive. Make sure that this is a 0 and not an O like you would type with like the letter O. And just make sure that everything is the way it should be here. and you should be good to go on this try. Here are some more activities that you can try to learn even more about this topic.